So thanks for having me. My name is Zhenlei. You can call me Zhen because Zhenlei is maybe is a little bit hard to spell. So I'm Android developing in 6. I've been developing Android since Gingerbread, so that means more than 10 years. And during my journey as Android developer, I saw many people struggling with Git. So my talk today is about Git. So I will tell some experience that I have with Git with you. I would like to share. So let's go to the agenda. So first I will give you a brief history of Git. Then I will go to what is Git, and then what is Git under the hood, so then you can understand better about the Git. And then you can go through some examples, and then you can learn some commands. And then we will see how to use the Android Studio with Git. That's really nice, the Android Studio with Git. And then some configuration for a big repo, if in case you work in a mono repo. So then you can take the most from Git. And last but not least, some final considerations, my opinions about how to use Git and so on. So a brief history of Git. Do you know this guy, Linus Torvalds? Is the guy that created Linux. Amazing idea to give the name Linux. So in 2005, he was working the operation system Linux, and he didn't like so much the version control back on the time. So what you do in this case, if you don't like the version control, just create a new one. So he created Git. And then you can ask, why did he give this name, Git? So if you check the dictionary, Git means a foolish or worthless person. I didn't know about this word. Git means foolish, worthless person. So he gave it this name because for him, Git is a stupid or worthless or foolish content tracker. I will explain later why he wants to say a stupid content tracker. Besides that, he gave another meanings for Git. So depend of your mood. So when you are in the good mood, the Git can stand for a global information tracker. You can check all those things in the Git documentation and also in the Git repository. And if you are in a bad mood or something breaks, there is this thing as well. I want to tell because they are recording. I don't want to record them saying these swear words. But if something's not working, it can mean this thing as well. And you can check this in the documentation and in the repository. Okay, cool. So what is Git? So if you check it in the repository, Git is a fast, scalable, distributed revision control system with an unusual rich command set that provides both high-level operation and full access to internals. So let's just underline 2 lines here. The distributed revision control. Why control system? So you can take a look at these 2 kinds of version control, the subversion and the Git. The subversion is there is a central repository, so it's a central control system. What does this mean? As there is only this central repository, is the single source of failure. If this thing is not working, nobody can use. And in your machine, you communicate with this central repository, so you need internet access. And with Git, it's slightly different. You have like a copy of the repository in your machine, or a mirror. So that means all the operations that you do with this local repository, and then you update with the remote repositories. So as we have this copy of the remote repository, it's a distributed control system. And why is an unusually rich command set? So if you see, do Git help, you can see many parameters and many commands that you can use. And more. And if you see on the one hand, this is amazing because you have so many commands, you can do so many things. But on the other hand, it's just one command to use. Or maybe there are many commands that you can use that do the same thing. So it's really complex. So, but let's go and dive deep and try to understand how Git works under the hood. Understand better how to work under the hood. Easy for you to understand and so on. So when Linus created the Git, he was expert in file system. So he defined Git as a file system, and he defined some model for this file system. The models in Git has a unique file, that's this SHA1, the secure hash algorithm. It's just an ID with 40 characters. You can see this in the GitHub, but GitHub just shows 7 characters. They short a little bit because if you write the 40 character, you won't see sometimes the title and the comments. And if you go to Android Studio, you can see 8. You need to use the commit ID, right? This ID. Don't need to write the whole thing. You can add 8 characters, 7 characters, 1. So in N26, as our repository is big, I try just write with 5. Decide to complain. There is 2 commits with the same idea. So that means there is a collision of hash. So then we need to use 7, 8. So the Git model, I can explain that it's main model. The first one is the blob. So the blob represents the files. And they contain the information. Yeah. So there is the blob. So the blob represents the file. They contain the information of the binary of the file and also the name of the file. And it is also the ID that represents this model. So we can see another blob that is inside a folder. So they contain the path of the folder and also the ID and the binary. So this is the blob. So basically when there is a commit or something, inside there is a file, that is the blob. And then the second mod is the tree. The tree you can think is like a folder. They have the information of the files inside. So as you can see, they point to these 2 blobs. You can have another tree that points to the files, and also can point to another folder, another tree. So this is the internal things that you usually don't see. What you see is the third model, that is the commit. So as you can see, the commit, they have the information of the tree. So they point to a specific tree. They have the author of the commit, the parent commit, and the commit message. Why this is so interesting? So the commit, they point to a tree. So this is like a snapshot of the current state of your project. So when we think about, oh, Git is so optimized because they keep the difference. They don't keep the difference. They have the snapshot. Why we say that there is the difference? Because when you have the previous commit, they also point to a tree. And those 3 point to different blobs. But if you didn't change the blob, the new tree, you point to the same blob, the same file. For this reason, it's optimized because they point to the same files. And all the tooling on the top of Git make this diff for you and show all those information. And the fourth model is the tag. And the tag is basically what you do when you do some release. They point to some commit. Cool. These are the 4 models. And besides that, as you can see, the commit doesn't have any information about the files. He doesn't know in the line 100 there is this information. They don't care. They just have the binary and the hash code on those informations. So as you can see, Git doesn't know anything about the content. So it's really a stupid content tracker. He doesn't know nothing about inside. So this is the reason that Linus Torvalds gave this name. It's a stupid content tracker. It's a Git. So if you go inside the folder .git object, you're going to see all the files, the file system that he mentioned. So if you delete one of those files, you just corrupt your Git, and then you need to pull again and clone the repository. Then there is this website that's really nice that I use to learn Git. And it's really cool because they show the graph of the commits. And then it's a game. So they show there are many levels. And each level, they teach you a new command. And then with those commands, you can use this terminal here to execute those commands. And your goal is to reach this graph here. So then you execute the commands, and the graph starts to transform, to modify, and then your goal is to reach this graph here. So if you don't know exactly the sequence of commands, you just click in the solutions, and then they will show the solution for you. So they show all the commands, and they start to see how the graph starts to change. And then you can understand what's happening with the tree. It's really, really cool. So I will share in the end the slides so you can take a look at the link. So in a nutshell, what is Git for me? Git is a graph of structure of file system, because it's in the files, with a bunch of commands to modify the graph. What is complex about Git? Because there are many commands. But basic Git is this. It's just a file system with a bunch of commands to modify the graph. So if you understand how to modify the graph, you understand Git. So let's learn some command through some example. So let's upload a new project to a remote repository. So we do this every time. So first, create a new project on the right example. We create a new project here. So let's set the default branch to be main, because nowadays we cannot use the master, so we just change to main to be the default one. Then you create a new repository, git init. So what did the git init do under the hood? They just created the .git folder for you with all the information and the file system for you. And as you can see, there is the head, config, description, hooks, info, object, and refs. There is one folder that's really interesting, is the hooks. I won't go so much in detail because I won't have time to explain, because hooks is a huge topic. But basically, hooks is really cool because every time that you perform some commit or push, you can run some script. So what does this mean? You can perform a link check every time that you perform a commit automatically. So more detail about hooks, you can go to this link here. Another thing that we did with the hook in N26 was every commit that we have, we need to add our ID, the jar ID, in the beginning of the commit. And it's so annoying to write this ID every commit that you do it. So we just created like a script that extracts the ID from the branch name, and that every time that you perform a commit, they just paste in the commit message. So we don't need to write this anymore. And this is less prone to errors, human errors. So there is also this file, gitignore, that ignore the files in the version control. So this is created automatically when you create a new project in Android Studio. But if you want a more complete gitignore, maybe you can go to this website, top-down, gitignore.io. You can write all the language, all the IDEs that you are using, and just click and create, and they will generate the gitignore for you. And just copy and paste and add in the project. So now let's add the files in your version control. So there is this command, git add, and the path. In this case, git add dot, so that you add all the files that I have in the stage area. So if you want to see what is inside, the status of your Git, so you do git status, you see all the files that's in the working directory and the stage directory. So you can see all the new files that I added, and all the files that are modified, and the file that's not tracked. And then now you can perform the git commit. So when you execute the git commit, what is the problem of this? They open the Vim. If it's your first time that you see the Vim, you'll be my feeling with this image here. I've been using Vim for about 2 years now, mostly because I can't figure out how to exit. So let's explain how to exit. So there is this first command that most people know, colon, W stands for write, and you quit. Cool. There is another one that's faster, colon, X, that you exit. So what's the difference between both of them? So the X, that you try to write if there is something that's modified. If you didn't modify at all, they don't save, because it's the same. And there is the third command that I like more, is in the Vim, they have some key bindings. What is this key bindings? It's some combination of keys that you do that they perform some actions. So in this case, the same action like this one is just to hold the shift ZZ. That for me is amazing, not because Z stands for Zhenlei, no. It's because Z is next to the shift key. In the French keyboard, it's not next, but in English keyboard, it's next to the shift. So it's shift, ZZ. So they write and quit. So it's easy. I don't need to look for colon or X, colon, WQ. But still, if you really don't like Vim, no problem. You can change the default editor to Emacs. Maybe you like Emacs. Maybe not. I hate Emacs, but maybe you can open the Visual Code. Or maybe Nano. Most people love Nano because it's really light. And then you can change the global editor. So instead of open the Vim, you can open another editor. Cool. So now you need to add the connection to other repositories. So you just git remote add the name and the URL. So this name is the name that you want to give to this repository. And the URL, for instance, in this case, is the GitHub there. That's the connection is SSH, but could be HTTPS. So when you add this command, then you add in this file, git.gitconfig, this line here. That you can see the name is orange, and the URL of the repository is this one. So every time that you push the code, they go to this repository. Why this is interesting? I never thought this before, but you can have this Sophia's repo. That is her machine. If you know what is the URL of her repository, you can give the name git remote add Sophia and the URL of her machine. So now you have also another repository, Sophia. So when the GitHub is down, you use the Sophia's machine. Nice. So you don't need to have only one, but maybe you have the GitHub, you have the Bitbucket or GitLab, three different repositories for some reason. And then you need to upload the local repository to a remote repository. So just execute the git push, -u orange branch. So you are pushing the code the orange to main. And then you have this -u, that's the upstream. So when you add this, they add this in the file, in the end, the branch main orange. So every time, the next time that you perform the push, you don't need to write git push orange name of branch. Then you know because there is this mapping. So you just need to say git push. So as you are in the main branch, they know that if you do the push, they go direct to this orange main branch, not to Sophia's branch or another branch. So this -u is for this. So now let's go to another example, create a new feature. So I think most of the people do this flow because I was doing this a lot, is when you create a new feature, suppose that we are working in feature A. So we have this asterisk because we are in feature A. So you want to start a new feature. But before start a new feature, you have here the remote branch and the local branch. So things that you see in the Android Studio. But let's change the name because the remote branch is really confusing. Let's call local remote branch. Why? Because remote branch, remote repository seems the same, but it's not. The remote branch that is inside the Android Studio is a local as well. So it's a local remote branch. It's just a mirror from the GitHub. So maybe it's outdated. So I prefer to call local. It's not a remote, because when you think about remote, it's the most updated. No, it's not the most updated one. So let's call local remote branch. And then you have your local branch. Then usually when you create a new feature, you go git checkout main, you go to main. And then you perform the git pull. So this command is really interesting because they do two commands at the same time. So the first command that they do under the hood is the git fetch. So they fetch all the code. So that means they update all the local remote branches to be the same like in the GitHub or GitLab and so on. So he just gets from the repository, the remote repository, the C4, the commit 4. Then they perform another command under the hood, that's the git merge orange main. And then they update your main with the C4 and update the head. Now what you usually do, you create the git checkout -b, feature B. So you create a new branch, and the head is still the commit 4. Then let's just commit a new commit here. So you have the commit 4, you point to the new head, right? But now imagine that somebody updated the main. So some pull request got merged in main. So what you need to do again, you go git checkout main, perform the git pull, they will do the fetch, they will do the git merge orange main, and then move the head. Now you do the git checkout hyphen to go back the feature B. Or you can do just git checkout feature B, but the hyphen they go to the previous branch that you were. So now you're in the C5. Cool. Now you can do git merge or git rebase, up to you. And then we create a new commit. What is the biggest problem of doing this kind of flow? As an Android developer, sometimes I want to test some bug, and usually I test the bug in a main branch. So I go to the main branch, I test something, and for some reason, sometimes I commit something by mistake in the main. And then the next time that I create a feature, this commit will be inside. So then I start to notice, maybe there is a better way to do this. So maybe, do I really need this local branch main? No, we don't need it. Why not use the orange main branch in this case? So let's see the same example. Work on feature A. So the first thing that we do is just put fire in the main. We don't need it. Just delete this branch. So now we have feature A. So what you do, instead of doing git pull, just do the git fetch. So just to update all the local remote to be the same like the GitHub or GitLab and so on. So we got the C4. Now we do the git checkout -b feature B, but I want from orange main. So then, new head, now I'm in the feature B. Cool. Now I create a commit. Yeah, there is a commit there. Now somebody changed the main, something got merged into the main. Do the git fetch. They update that. Now we just need to do git rebase or merge. I prefer rebase. And then git rebase orange main. I'm moving forward. Cool. What is the advantage of this? I didn't change the branch. I'm always in the feature B branch. I don't need to switch to the other branch and come back, switch back, come back. For me, this is kind of annoying. But if you are used to this approach, just follow, because it doesn't have the correct way to do it. It's the thing that you are used to, just follow the thing that you are doing. So what is the difference between merge and rebase? Because one example I use merge, another one I use rebase. So the merge one, I will just give you a quick overview. So we have the git merge and say what is the commit or the branch name. So I'm in the feature B. I do git merge with the feature A. So they do the merge. They create a new commit, the commit 4, and they merge the C2 and C3. And if you have some conflicts, the commit 4 contains the resolution of the conflicts. Now I ask you, what is the parent of the C4? C2, C3, or both? Both. So then, if you need to execute some git command, more advanced command, maybe you need to define what is the parent that you want to follow, the first parent or the second parent. So there's some command that you need to pass those parameters. And beside that, when you do so many merge, it's really tricky to see the history of the Git. So you end up with this Git spaghetti. I love food, but in this case, it's really tricky to see the history. And there is a nice Twitter that I saw. It's a new name, Gitarero. So this is another thing as well that I saw. And beside that, if you check the pull request, just wait for her to take a picture. No, you can take a picture. No, take your time. Okay. So another thing as well is if you check the pull request, you're going to see some merge in the history. So there is merge. So it's a little bit tricky to review the pull request if you have so many merge in the history. And then, and the rebase. How is the rebase? I do a slightly different. Instead of start by commit 3, suppose that you have a commit 4 here, just to make clear the difference between rebase. So let's do the git rebase with the feature A. So the name rebase means rebase, new base, new base. So the feature A will be the new base. So let's think the feature A is the new base. C1, C2 is the new base. Now we're going to take the B, put it on the top of the feature A. That's the new base. Okay. Let's copy the C3, the commit 3. So you can see commit 3 single quotes. It's a copy on the top of the commit 2. And then you take the commit 4, C3. So now you have just one line. You don't have this spaghetti. So the history is super clean. It's like commit 4, commit 3, commit 2, commit 1. But keep in mind the commit IDs are different. You are changing the history. What is the problem of this in this case? If you create a pull request before with these 2 commits, and now you try to push the code again, then you say, oh, fast forward, your commit IDs are different. You cannot push the code. But then there is the most dangerous command. Git push force. So basically they say, just ignore what's in the repository, push my code, I trust my code. Just do this, and then you just override that. So if it's in the pull request, amazing. do it because it's your pull request. If you fuck up, I said a bad word, but if you fuck up, it's your pull request. It's okay. But I worked in a company before that I don't want to say the name, but the guy did a git push force in master or in the main because it was not protected. So we lost 1 month of code, but Git is distributed version control. So we took our local repository, the copy one, and we did a push force on the top of his push force to recover the 1 month of work that he destroyed. And then we saved the code. So the git push force is a little bit dangerous. There is another command, the git push force with lease. What does this command do? Basically, when you are doing the rebase to change the history, they check if somebody changed the tree or something got merged in the branch. If this thing happened, when you perform the git push force with release, they will just block you. You cannot push force. So it's just a layer of protection. OK, there is another command that is really nice about rebase, is the rebase interactive. I stands for interactive, so easy to remember. So let's try to do this git rebase head till 4. So basically, you on the head, I want 4 position before. So C5, 1. It doesn't start by 0. So 1, 2, 3, 4. If you don't like head till 4, you can use rebase interactive C2. Up to you. Then what does this do? They open this ugly terminal with this VI, vim, with say, you can perform those commands. P or pick, R or reward, E, edit, S, squash. So let's just use some commands. So pick is to pick one, reward is if you want to edit the commit message, edit if you want to edit something in this commit and change. You can squash, combine commits, and so on. So let's make the first one to edit. As you can see, I just use 1 letter. But I can write edit. It's like squash. I just wrote squash, but I can use just S if I want. So let's see with edit and squash what happened in the tree, the graph. So as a base, the C1 will become the new base. So they perform first the copy of C2. Then you edit this commit 2, and they become like a commit 6 because we added. Then they will pick up the C3, is the copy. Then they squash with the commit 4. Squash it. And then now they pick up the commit 5 and copy. Cool, right? So basically, we went back to the time and changed the history. This reminded me so much a movie, Men in Black. Do you know the flash stick that when they light on, so they basically erase your memory and give you a new memory for you? It's like the rebase interactive. Really cool. Then, so okay, another example now. When was the bug introduced? So sometimes you are working a project and there is a bug, and you need to find where is this bug was introduced, when this bug was introduced. So let's take this example, this repository. So you see there is these 2 tags from 1.5 and 1.6. Imagine that some bug was introduced here. So you go through all the commits and, OK, let's try to find when the bug was introduced. So sometimes you start to take a look at the title to see if it makes sense, if it was introduced here, but it's not a good approach. So we start to use, maybe I can use something from the university, binary search. But usually the binary search is a little bit tricky when you are human and try to do by yourself. Why? You go to the mirror, OK, but I don't like this title. Let's take a 1 above or 1 below. So you don't follow through the binary search. But Git provides you the git bisect. That's the binary search for you. So, and the git bisect, there are 5 main commands. The first one is the git bisect start, that you can define what is the bad commit and the good commit. So it can be head, the bad commit, because its current is failing, and some point in the past that is working. If you don't define anything, you need to define the git bisect bad, what is the bad commit, and then the good commit. So when you have the interaction of the git bisect, they will tell you, this is the mirror. And when you test, you need to say to the tool, is good or bad? And then they will show another commit. Is this commit good or bad? And you need to say, oh, git bisect good, git bisect bad. And then in the end, oh, now this is the one that we are looking for. Besides that, if you don't know, you just say git bisect skip. But not only this, but there are some commits that is not worth to test because it's not compilable. So if you, instead of using Hebase, use too much merge in the main, you're going to see there is many commits that's not compilable. So in this case, you can add a list of skip commits. And when you find the culprit or the commit that introduced the bug, you just use the git bisect reset to reset to the beginning where you were before, so you can start working again. Cool, so this is a visual representation, how it is. So you have the broken one and the stable. You apply the git bisect, they will tell you, this is the middle one. Is it working or is it not working? And you just say, oh, it's working, so git bisect, good. So they go to the right side. If it's bad, they go to the left side. And then they will tell you what is the commit that introduced the bug. But git bisect can be even better. You can also run a script. The problem to run a script is to write the script. And the script, in this case, is in Bash. You can make a script in Bash that will run UI tests, many other things. But you just need to keep in mind that as is a Bash, the return is a little bit weird because if it's 0, the return of the script means the commit is good. If it's 125, the commit can be tested, so skip. And the other number, usually they use 127, is a bad commit. So if you run this, they will do all the automation for you, and then this is the commit that's with problem. Cool. So Les, Houston, we have a problem. Maybe you faced this issue before. You work in different tasks. You are working different branches, and by mistake, you delete one branch with some commit that you have there that you want to use, but you lost. So then you say, okay, now I need to write everything again because in the Android Studio, the local history don't keep those histories because you deleted the branch and so on. But it's okay. I can revert this by going to the ref log. What is the ref log? Ref log is similar to Git log. The difference is they keep the log of all the changes that happen in the head. So that means you delete a branch. Okay, you just change the head. You did a commit long time ago. They keep in the ref log. And then, for instance, there is this commit here. There is this the hash, and you can use. So you can go to this point. Just do a git reset heart, and go to this commit, and you can recover the code. So you don't need to write all the code again and try to remember what did you do before. Cool. So now Android Studio and with Git. I will go a little bit fast because this part, I guess you are using this a lot, and also is pretty simple. Is, for instance, create a commit. So you can use Command K, or you can use the right button and create a commit. But I love shortcuts, and shortcut has some meaning. Why K? Because it's Kotlin? No, because it's commit. But commit start with C. But if you do Command C, it will be copy. So you have conflicts. So what is the other letter that's similar? K. So Command K. Easy to remember. So the next one is the push. So if you want something more special, just add Shift. Command Shift K. So they do the push. Similar to commit, but go to the remote repository. So you can change the name of the branch. You can do the push. If you click in this button here, in the next, they will show push force. And then there is the tab, the Git tab, Command 9. Maybe 9 is like a G upside down, I don't know. But find a way to remember the shortcut. So then this is the tab that you most likely know. So this side you can see all the branches. This part here you can filter out. I usually make the branch to be just the head, so I just see things in the head. And the user is usually just me, but you can filter out. And then this side you can see the description of the commit, more detail about the commit. If you click on the right button, you have so many options. You can create a patch. This is really cool because they create like a file. You can send to your friend through an email, and they can apply. Instead of you saying, oh, go to the line 105, add this command here, this code here, and then try to run the project. No, just create a patch and send to the guy, and the guy just apply. There is the cherry pick. You can see a cherry pick, like you pick a commit. You can also you can edit the commit message. You can also squash, drop commit, and the interactive rebase. That for me is really nice, the interactive rebase, because you saw before how it's in the terminal. It's really complicated. You click this, they will show this amazing visual interface. So you can edit, you can reword, you can squash, and they do for you, and then you can start the rebasing. Really cool. And then there is the git blame. It's not to blame your friend. It's more you to have more context what's happening. So usually what I do is I click on the right button, and I open on GitHub. So I can see in the GitHub the description of the pull request, if the person writes a nice description in the pull request. So in my company, the description is way better than the commit message, because we usually don't write commit message, just the title. But the pull request, we try to add a really nice description. And beside that, when you open the GitHub, you can know as well in which version you release this line of code as well, because you can see in the labels, in the tags on the top. So this is really cool. And Git conflict. This is amazing because Android Studio handle pretty well Git conflicts. And then just wait for the last guy, this guy. So nice. Poof. So it's really good to handle mesh conflicts. So you see there is the first column, that's your code, the thing that's in remote, and the thing in the middle that you want to merge. And there is also a magic wand here that they solve sometimes the conflict for you automatically. So you just need to trust. Not always, but you take a look. And pro tip, because I love shortcuts. You can create a shortcut for fetch and branches. You execute the command Shift A. A stands for actions. If you don't like to remember this, Shift, the most basic one. So then you go to, and you look for branches. When you find the branch, it doesn't have any shortcuts. So you do Option Enter. Option Enter is like helping me or show me more options. So then you open the keyboard shortcuts. Let's give a shortcut to branches. Which shortcut would be easy to remember? B, right? Let's do Option B. If you try it, you say, oh, conflict, because you have conflict with breakpoint. So I cannot use B. What is the other letter that's easy? Main menu, oh, Git, G. So Option G is a good shortcut for me. And then you create one for fetch, Option F. So I have these two shortcuts. Why, for me, these two shortcuts are so important for me? Because when I create a new feature, I just do Option F, fetch successfully. All my remote, my local remote branch is updated. So now Option G, they show the branch. I just look for master, go and I create a new branch from there. Done. I have a new branch, a new feature that I work on. And then it's really well, if you use a GitHub, it's really, really well integrated. So the plugin is already installed automatically. So with the GitHub plugin, you can create pull requests. You can also review pull requests, add comments, and so on. And not only this, but you can also try to add the iTerminal and OMyZH. Because one thing that I miss when I move from Linux to MacBook is Git doesn't have autocomplete in Mac. But if you install the iTerm and OMyZH, OMyZSH, then you have autocomplete. Also, they add so many aliases. So if you write alias, pipe, grep, git, you're going to see so many aliases. So you can go through and see, oh, this command I use a lot. You just need to remember the alias. So if you want to know more about Git in Android Studio, you can watch this talk from Marto, a really good presentation. So he has like 45 minutes or 40 minutes just talk about Git in Android Studio. So, okay, now let's go to the configuration in your mono repo. So if you work in a big project, in a big repo, so this is some configuration that I recommend you to do it. So the first one, if you are using GitHub, sorry, I will use GitHub, so I just know more about the GitHub. So in this case, what we usually do is we remove this option, allow merge commit, we just allow squash merging. So if you do this, your main branch will be smaller because they will squash all the things in your pull request and create only one commit and add in your main. So the graph will be smaller. And also, each commit now in the main is compilable because for sure you have some CI that run your pull request, the last commit your pull request, to see if everything is passing. But usually we don't check if every commit in your pull request is passing, but only the last one. So squash merge is important for this as well, in case you want to use the Git bisect. And rebase merging is also the same because they do the rebase. You have different commits there, and maybe some commits doesn't compile. And the last option here is delete the branches that is already merged, so you don't need anymore. But if you want to recover, don't worry, GitHub will recover for you. But you can delete it. And why this is nice? Because you can add this configuration in your Git now. You can enable the auto prune. So you can enable globally or locally. So what does this mean? Every time that you perform a fetch, they will delete all the branches, the remote branches that's not used anymore. That's deleted. So you can see here, this is deleted, this is deleted. So you make your Git a little bit faster. So you want to receive a message. Now you need to do garbage collection in your Git because there are so many nodes, many commits or nodes that's not reachable anymore. Cool. The last configuration is kind of new. If you are using Git version 2.37, you can enable the FS monitor, the file system monitor. So basically, it's a cache. What does this do? So for instance, some commands like git status and git add that need to go through the tree, through the graph of Git, and this can take some time. In N26, our project is slightly bigger, not super big like Facebook and the other companies, but it's big, not massive. And it's taking 1.73 seconds, almost 2 seconds, just to do the git status. Then, if you enable the FS monitor and also the untracked cache, that's basically the git ignore. So every time that they go to each file, they check in the git ignore, is this file ignored or not? So this takes time. So if you enable this cache as well, also you make it faster. Then you execute again the git status. Okay, the time is higher, 1.93. But the first time that you're going to run, they will just warm up the cache. So just wait. The next time that you execute the command, boom, now it's 0.02 seconds. So we improve the time from 1.73 to 0.02. Okay, 2 seconds is not too much, but if you have a massive project, maybe it can take 10 seconds, 20 seconds, or 1 minute, maybe. So then, having this kind of cache will help you a lot. Final considerations. So the first one, there are more Git commands to explore. I just explained a subset, just few commands. There is cherry pick, reset hard, soft, and so on. There are many commands. So I just showed some subset. So the idea is to you to understand how Git works under the hood to help you to understand the new commands for you. Because it's impossible to explain all the commands that exist, even though I don't know all the commands. So I just know the command that is useful for me for now. And there are many ways to do the same thing that I explained to you, how to create a new feature. Try to find one that fits you, that works for you. So if for you don't change the name at all, okay, go to this approach. It's not bad. So it doesn't have the correct and wrong. There is the thing that works for you. Last but not least, there is many resources. There is this web page that I was explaining. I always share this with everyone because it's super nice game, because everyone loves games. Everyone hates books, but I like both. And use the command line as well, like git commit -h. H stands for help. They will show all the parameters that's supported. And try to understand the parameters sometimes. And if you really like books, there is this free book from Git documentation. It's really good, this book. So there are many ways to learn Git. And more I study Git, I feel this quote here. The more you know you don't know. So this is my feeling for Git. But at the same time, more I study, more I learn. That's super cool as well. So just enjoy the journey of Git. Thanks. So I will publish the slides in my